hit the button.
Hey, guess what?
Okay.
Did you do it?
Hey, hey.
So, back side of the note, so properties of logs. Example, number 9. You are asked to evaluate log base B of 1.5.
It's 15.
Oh, it's 15, okay. Log base B of 15. If you are asked to give this a value, then you have an equation to solve that has one log in it. You're going to hear me say this. You have heard me say this over and over. You've got to get this in your brain. You have an equation to solve with one log in it. Your strategy is change it to exponential form. Say the same thing another way. So if you say the same thing another way, a log equals an exponent. B is the base. This sentence means B raised to some exponent equals 15. Well, you can't solve this. We're stuck.
Oh boy.
Because we have an unknown base, unknown exponent, too much unknown. You can't solve it. At least not go in this direction. But if you consider the fact that you are given some information, and this problem can relate to the information you're given, if you think about another way to say 15, you could say 15 is 3 times 5, and we know something about log base B of 3. We know something about log base B of 5. So if we try a different approach, and we rewrite this as log base B of 3 times 5, y'all remember last time? We learned some new properties. We said if you have a logarithm is an exponent, remember? Logarithm is an exponent. There are properties of exponents. When do you add exponents? If you're multiplying. So we had a property last time that said the log of a product can be rewritten as the sum of 2 logs. So we're going to expand this out. You had double arrows on those properties, meaning you can go from 1 log to expand it to 2 logs, or you can go from 2 logs and condense it down to 1 log. You can go both directions. So if I use a property of logs, then this is log base B of 3 plus log base B of 5. Now I can work with it because I have given to me log base B of 3. What is it?
1.5.
And it was given to us, log base B of 5 is 2.2. So if I use the information, I couldn't get a value for it going this way. But if I use the information that I'm given, I can come up with a value for log base B of 3 times 5, log base B of 15. Log base B of 15 equals 3.7. On number 10, got to do something similar. Log base B of 125. If I tell you, give me a value for this, then you would tell me, well, okay, this means a log equals an exponent. So some base B, or base B raised to some exponent should equal 125. And then we're stuck. Because I don't know what the base is. If I don't know what the base is, I can't figure out what the exponent is. So we're stuck on this one. But if we try a different approach, what's another way to talk about 125 so that it relates to what we know, 3 and 5? To do that. Here, you could say not 5 plus 5 plus.
Yeah, right.
It's log base B of, you could do 5 times 5 times 5, or you could do log base B of 5 to the 3rd.
You could also.
If you write it as 5 times 5 times 5, then you got 1 log of a product. The log of a product can be expanded and written as the sum of logs. So log base B of 5 times 5 times 5 could be written as log base B of 5 plus log base B of 5 plus log base B of 5. We know what log base B of 5 is because it was given to us. 1.5. So, no, I'm sorry. Log base B of 5, 2.2. So 2.2 plus 2.2 plus 2.2 turns into 6.6. Now we can give a value to log base b of 125, only because it relates to what we've been given. We could also do this, log base b of 5 to the third power, a log is an exponent. What happens if you have an exponent raised to another exponent? What's the rule? You multiply the exponent. So if I multiply the exponents, that means 3 becomes a multiplier. 3 times log base b of 5 means I could do 3 times, I have a value for log base b of 5. It was 2.2. And 3 times 2.2 also gets us to the same 6.6. Okay? Your homework page that I have for you today has a couple of problems like this on it. Below, on the next set of group of problems, it says the base change formula. We're going to get to that in a minute. Solving an exponential equation using logarithms. So we're going back to working with that. We're kind of working back and forth between exponential equations and logarithmic equations, and you have to be able to work with both. I told you there's 3 strategies for solving exponential equations. Remind me. 1, like bases, trial and error, take advantage of a property of logarithms, and that's what we're going to practice on these. So, on number 11, there are no logs in this equation. It is not a logarithmic equation. It is an exponential equation, because when I look in the exponent position, I see a variable. So we'll think about what options we have, like bases. If I think about, well, maybe I could get the same base of 4. If you think about powers of 4, 4 to the first, that's 4. 4 squared, that's 16. 4 to the third, that's 64. 4 to the fourth, that's 256. We bypassed 124. There's no way to get a like base for these two. 2 doesn't work either. You can't get a like base of 2 or a like base of 4. So that was out. Trial and error, we've done this problem before using trial and error. But option number 3 is the fastest. Take advantage of properties of logs. If you take a log of both sides, log of 4 to the x equals log of 124. And then you get, how does this help us? What's the base?
10.
It's understood 10. I've got a log, that's an exponent, raised to another exponent. What do you do when you have a power to a higher power? So this x can become a multiplier, and so x times log of 4 equals log of 124. You can't just cancel logs, but solving this equation is no different than if I said solve x times 10 equals 20. What would you do to get, you divide, okay. So to undo a multiplication, you're going to have to divide. Okay, log 4 divided by log 4 is really 1. So yeah, you can cancel those factors.
I have a question there.
Okay, hold that thought 1 second. So if I ask you for the exact answer, you're going to tell me the exact answer is log 124 divided by log 4. But I want you to give me an approximate answer, and you're able to do it on this problem because no base is written. It's an understood base 10. So type into your calculator log 124. When you do that, it will automatically open a parentheses. Be sure you close it before you divide by log 4. Tell me what you get approximately.
3.477.
When we did this by trial and error, we got about 3.477. Okay, Eli, go. What's your question?
I thought if they have the same bases, you can just disregard those logs and simply but is that not the case?
Well, if you do, here's what will happen. If you got log base 10 equals log base 10, so what would be true? 4 to the x power equals 124, and you're right back to here, and you don't know what x is.
Okay.
Okay? So you're right. You're right. If it's log equals log, then it has to be true that 4 to the x equals 124, which is where we started. We already knew that. But the only way to find a value of x is to go through this process. On number 12, this equation does not have any logs in it. It's an exponential equation. It's in the form a multiplier times b base raised to the power of x. So 8.62 times 5.24 equals 2435.3. Tell me what your instincts tell you to do first.
Divide by
Divide.
8.62.
Would be good.
You're right. You want to isolate the base. So if it's an exponential equation, get the base by itself. So you're going to have to divide both sides by 8.62. And you can cancel factors. So you have 5.24, I forgot the exponent, 5.24 to the x equals, your calculator can handle 2435.3 divided by 8.62. So this is an exponential equation. You think like bases are going to be a good option. 5.24 and whatever this is, probably not going to find like bases for those. Trial and error, it's not going to be very much fun. So our third option is take a log, and a natural log works too. If we take a log of both sides, log of 5.24 to the x equals log of all of this stuff. You got to know about properties of logs to understand how this helps us. A log is an exponent raised to another exponent. When you have a power to a higher power, you multiply. So the property of log that we use is the one that says multiply. Multiply the exponents. Multiply x times the log. So x times log 5.24 equals this. What would I need to do to solve for x?
Divide.
Yeah, I got x times something, so divide. So x, we divide by log of 5.24 on both sides. It looks like this. You have log of everything on the top, 2435.3, divided by 8.62, all divided by log of 5.24. If I ask you for the most exact answer you could give me, that's it. But give me an approximate answer. So you have to be careful, because when you type log on your calculator, it automatically opens a parenthesis. So log of 2435.3 divided by 8.62, close the parentheses, and then divide it by the other log. Tell me what you get, approximately.
I got 3.4074.
I agree. Okay? Work on number 13. What are you going to need to do first?
Divide.
Yep, you want to get the base by itself first. So divide and isolate the base. You have multiplier times base to an exponent that has a variable in it. This is an exponential equation. So if you isolate the base, you got 5.7 to the 3x plus 4 equals whatever this happens to be when you divide it. You're probably not going to get a like base for 5.7 and 15 divided by 4.1. Trial and error wouldn't be very much fun, especially the way this exponent's written. So our third option is take a log of both sides. If you take log of 5.7 to the 3x plus 4, then whatever you do on one side, you must do the same on the other side. And then you notice that you have a log, which is an exponent, to another exponent. That means multiply. So if you multiply, you have 3x plus 4 all times log 5.7 equals whatever you get when you do 15, log 15 divided by 4.1. In order to solve for x, keep in mind, here's your variable, we're trying to solve for x. The first thing we have to do is undo this multiplication. Divide both sides by log 5.7. So in your calculator, do this right quick. Type in log 15 divided by 4.1. Do this. Close parentheses. Divided by log 5.7. Close parentheses. Enter. When you get an answer from calculating these two logs and dividing, what you have now represents, I'm going to go up here, 3x plus 4 equals whatever number you have from doing this division. So to solve for x, what will you finally need to do? You've got this number still on your screen, then what?
Subtract 4 divided by 3.
Okay, subtract 4 and divide both sides by 3. 3x is equal to some number. And then when you divide both sides by 3, what does x equal?
-1.0849.
That's it. Negative 1.0849. Did you agree? Okay? Okay. Finish star by number 14. Look at it for a minute. Guys, it's a little tricky looking because there are no numbers in it. You have log base b of some argument n equals x. So if you look at this, you say this equation is a log equation. It has one log in it. We have a strategy. Our strategy is whenever we have an equation to solve with one log, we're going to say the same thing another way. X is the exponent because the log always equals an exponent. B is the base. So base b raised to the exponent x has to turn into n. If I'm going to try to solve for x, I can't get like bases because I don't know what b and n are. I can't even use trial and error because I don't know what b and n are. But if I take a log of both sides, log of b to the x and log of n, then I can take advantage of the property that says if I have a log, that's an exponent, raised to another exponent, this can become a multiplier. So x times log b equals log n. How do I solve for x? You're going to have to divide both sides by log b. Here's the deal. If you are trying to, this is the change of base formula. If you want to do something like example 15 on your calculator, log base 6 of 8. Before now we have said you can't do that on your calculator. Why? What can you do on your calculator?
You can always do base 10.
Base 10 or base E, natural logs. This right here gives us a change of base formula. What really ends up happening every time, if you want to do log of any base, like log 6, log base 6 of 8, it turns out that you will always do log of the argument and divide it by log of the base. So this is a change of base formula. Log of the argument divided by log of the base. It lets you have a way to do log base 6 on your calculator instead of just log base 10 or base E. So we're going to pretend for a minute, y'all still with me? We're going to pretend for a minute that we didn't just talk about the change of base formula because you may not quite have a grasp on it yet. But if I work through this problem and I say, I'm looking for a value for this, I'm going to make it a sentence, make it equal y. I've got an equation to solve. It has one log in it. What's our strategy? Say the same thing another way. 6 to the y equals 8. Write it in equivalent exponential form. Now I have an exponential equation. Are there like bases for 6? Because I got 3 options, 3 ways to solve exponential equations. Like bases, trial and error, take a log of both sides. Can I get a like base for 6 and 8? They have a common factor. 2 is a common factor, but it's not a common base. 2 squared is 4, 2 cubed is 8. We never get a 6 anywhere. You can't get like bases. Trial and error, we don't want to do that. So our third option is take a log of both sides. If we take a log of 6 to the y, and we also take a log of 8, and I'm not putting a base here, so I'm understanding it to be base 10, which means I can punch the calculator. How does this help? If we take a log of both sides, then I have a log raised to an exponent. That's like a power to a higher power. That means I can take advantage of the property that says y becomes a multiplier. So y times log 6 equals log 8. If we divide both sides by log 6, then really, what have we done? When we've gone through this whole process, the shortcut is, if I want to do this on the calculator, I know I'm going to have to do log of the argument divided by log of the base. Every time. Do it. Punch it into your calculator. What is log of 8 divided by log of 6? So, y is approximately 1.16. Oh, is it 06? 06.
Yeah, because if you didn't round it like that, it would be 5.5. But no, it was after it, so.
Okay. Do number 16. Do log base 3.7 of 45.6. You have the choice of going through every bit of this. And before now, we would have said, we can't do that because it's not base 10 or base E. But now you can. Chase, are you still here?
Which one?
Well, it just worked for both of you, but I was really...
No, I was doing it.
I was looking back.
I already have it done.
You got it?
Exactly.
So tell me what you got.
I have
Yeah, Chase.
Number 16,
16, yes.
2.9197,
How'd you do it?
log of 45.6 over log of 3.7.
Exactly, very good. So, if you look at a problem and you see that it's not base 10 or base E, and we have, up until now, we have said you can only do base 10 or base E on the calculator, but now you know a change of base formula, so you can do log of the argument divided by log of the base, and you got 2.9197?
Yes.
Okay. Read number 17.
That's your fault.
Your fault. Your fault.
Determine the time required for a $4,500 investment to reach a value of $12,500 if it is compounded monthly, circle those words, compounded monthly at 8.25%. So this is a formula that I want you to know. The amount of money after time
Isn't that just tax? 8.2?
is the original principal. This is the compound interest formula. It's not the PERT, it's not the one that's compounded continuously. It's A equals P times 1 plus, y'all remember when we did that example? And we said if you're going to compound the interest 4 times a year at 8%, you don't get 8% every time you figure the interest. You have to divide the 8% equally. So you always have to divide whatever your rate is into equal parts depending on how many times you're going to compound the interest. And you raise that to the n power times t, however many years you're going to do it. So this is a formula that you need to put in your brain for calculating interest, or calculating the amount of money you have after time, compound interest. So where are you going to put the time required for a $4,500 investment? What is $4,500 in the formula?
That's T, right?
That's T, principal. That's the money you start with. And you want it to grow to be $12,500. That's the amount after time. And our interest rate is 8.25%, but you don't divide something with a percent sign in it, so yes, you have to change this to a decimal and make this 0.0825 divided into, yes, compounded monthly. So we're gonna calculate the interest 12 times a year. 12 times a year for how many years?
1 year.
Not in this case.
No,
What
we
does the
don't
question
know.
ask you?
asking how long for the year.
You're looking for the year.
Is
It
that
says
what it is?
determine the time, put a box around that. You were trying to figure out what the time is.
Correct.
So you were trying to solve for a variable that is in the exponent position, which means this is, yes, this is an exponential equation. You got multiplier times base raised to a power, listen, you got multiplier times base raised to a power that has an exponent, a variable in the exponent position. Isolate the base first, so if you divide both sides by 4,500, then we can cancel some zeros here. Your calculator will handle 125 over 45, so I won't worry about reducing that. But it equals 1 plus 0.0825 divided by 12 raised to the 12t power.
What does
So we
the
got
N
to
stand
analyze this. I'm sorry, go
What
ahead.
does N stand for?
N is how many times we're going to calculate the interest. So
Okay.
if it's compounded quarterly, N is 4. If it's compounded monthly, N is 12.
So it's just, alright.
Daily, N is 365. So it's how many times are you going to figure the interest in a year? So I've got an exponential equation because I look in the exponent spot and I see a variable. So I've got 3 options, like bases. 125 over 45, and this, you think like bases are going to happen? Like basis, not going to work. Trial and error would not be an easy situation with this. So we'll take a log of both sides. It'll also work if we did a natural log, but because natural logs have all the same properties that log of any other base does. If you take log of both sides, how does that help us?
It's gonna allow you to get that exponent. It helps the
Exactly.
Yeah.
It is the way to get the exponent, to get the variable down out of the exponent position. So, because I've got a log to another power, that means 12t can become a multiplier. So,
Hold on.
okay,
Are we on 17?
Yep.
yes.
I'm severely confused.
Okay, let me start over and I'll review. So we have 4,500 originally, and we want it to grow to be 12,500. So we put 4,500 in as the principal, and we wanted it to turn into, after time, $12,500. So we plugged into this 1 plus our rate is 8.25, so we changed it to 0.0825. The interest is going to be calculated monthly. So it's always over n. Number of times we're going to calculate the interest is 12. Raise it to the power of 12 times t.
Oh.
No, that's what I was getting wrong.
So we got to solve for t. It's an exponential equation. We said take a log of both sides. Are you okay now?
I'm sorry, I seriously thought that it was like,
It's okay. It's okay. So if we take a log of both sides, then 12t becomes a multiplier. So here's where you are. Log of 125 over 45 equals, now 12t is a multiplier times log of all of this 1 plus 0.0825 divided by 12. Oops, I forgot my 12t. So if I'm trying to solve for t, here's what I would probably do first. You got to take log of all of this, and if we're trying to get t by itself, I'm going to first get 12t by itself. So divide on both sides by log of 1 plus 0.0825 divided by 12. Type this into your calculator. You have to be careful and put in close parentheses. Type that into your calculator. Log of 125 divided by 45, close parentheses, divided by log of 1 plus 0.0825 divided by 12, close parentheses. Type that in.
By I, I mean trees.
When you type that in and hit enter, you have some number on your calculator screen, and what does that number equal?
It
Equals.
What do we have on the other side?
12t.
That equals 12t.
So you have to divide it by 12.
So then you have to divide by 12.
Then you can get
You like going?
When you divide both sides by 12, what'd you end up with for time?
I got 12.4262.
Bingo was his name.
Okay.
It was.
So if I round about
So your,
12.43 years
name
is
is
the
now
time.
Bingo.
Yes. Push to that one.
Are you okay? Not really.
You lied to me.
I don't ever lie to you. What are you talking about?
Oh, that's, there's another lie right there.
Get again.
Uncontrolled liar.
Work on 16, work on 18.
Somebody lies once doesn't mean they're a liar.
Work on 18.
This child's greatest so far.
Oh, no, I'm
Same.
done.
I quit. Oh, what did you done?
That's what I would be.
No quitting now. So, well, no crying in pre-cal, just like baseball.
It's not too late for this. What?
An investment of $5,000, listen, an investment of $5,000 increased to $13,000 over a period of 3 years in an account that was compounded quarterly. Circle that.
Quarterly.
Compounded quarterly, anytime, if it's anything other than continuously, then you start with this formula. Memorize it. The amount of money after time is principal, the original amount, times 1 plus your interest rate divided by however many times you're going to compound it, raised to the power of n times t.
To the power of raw.
So if you plug in, where's 5,000 go?
To Jamaica.
That's the money you start with. That's the original amount. 5,000 goes where P is. You want that 5,000 to grow to be 13,000, or it did grow to be 13,000. Over a period of 3 years, in an account that was compounded quarterly, but the problem is we don't know the rate. So 1 plus, we don't know the rate, but compounded quarterly, what means what? N equals 4. You do this 4 times a year for how many years did this happen?
3.
Is this an exponential equation?
It is.
It is right now.
It is as
No.
It
No.
doesn't have a variable in the exponent.
It doesn't.
So on this one, solve for r. If you divide both sides by 5,000,
That's a big 5 grand.
13/5 it reduces to be,
True, it does.
equals 1 plus the interest rate divided by 4 raised to the 12th power.
Yes.
I need the 12th power to go away.
So you do. Oh, you
Make
do.
it a
12
law.
square roots.
You make
What?
it a law.
Not
12
12.
square root.
It's not called the 12th square root, it's just
It's
called
13
the
to
12th
the 12th
root.
root.
You can either do a 12th root, or you could raise it to the power of, what means the same as a 12th root? 1 over 12,
You can't
1
just
12.
make up things.
Okay, y'all be with me, we're nearly finished.
Yes, ma'am.
So, you could take a 12th root, or you could realize the same thing as the 12th root is raising both sides to the 1/12th power, because the rule says when you have a power to another power, you multiply. And if you multiply 12 times 1 over 12, you just get 1.
Oh boy.
So if you raise the right side to the 1/12th power, you gotta do the left side to the 1/12th power. So type this into your calculator. Parentheses, 13 divided by 5, raised to the power of 1/12. Tell me what you get.
The power of raw.
1.082288.
Okay, just keep that number on your screen. You get some number on your calculator that is now equal to just,
I got .216.
okay.
So you would think so.
You got what? I don't know, because I don't have it written.
You gotta put one to wrong.
.2167, okay. Keep the number, you gotta have
I got
parentheses.
1.8, 1.0828.
I got it.
Did you type it in just like this? Parentheses,
I got
13,
pretty
divided by
much.
5.
special ones where you don't necessarily have to
Did you
put
make-
parentheses on
Okay.
the exponents.
Did you make it come down? Did you hit the right arrow key to make it come down? I'll look at it. I'll look
Wouldn't
at
you
it.
just subtract 1 and then multiply by 4?
I'll look at it in a second.
Okay.
So now you have this. You are to where you have some number on your screen and you know that it equals 1 plus rate divided by 4. So in order to solve for the rate, I need to subtract 1 from both sides.
And then
So whatever number you have on your screen, subtract 1 from that. Then you have a new number on your screen that is equal to
it is
r
.082.
divided by 4. Okay.
So you multiply by 4.
So then you multiply by 4.
Oh, shit.
When you multiply both sides by 4, you should have landed on r is 0.3315.
Can you just do 3.32%?
If it's 0.3315, what is it as a percent? You gotta move that decimal 2 places, so
30.15. Oh, wow.
33.15%. Which is a pretty unusual interest rate. Not very many places are you gonna be given an interest rate of 33%.
You put like $5 in there, you get like $20 million back.
Okay, Jeremy, you can turn that off.
Should I say
Press the button.
Hit the whip.